Okay, so this is your new lab for this week. It is going to be an exercise using Google Maps. Think back to week 1 and 2, we used something called Google Earth and we looked at the plate boundaries, and it's a very useful software for a lot of things. But probably in your everyday life, you're going to be using Google Maps more. And probably some of you use the iPhone Maps app. But Google Maps is really helpful for not just navigation, but for also getting to know a landscape. So, we're going to start a topic today called topographic maps. Let's see what a quick Google search comes up with for that. Topographic map. It concerns the shape and character of the Earth's surface. And these maps were among the first artifacts to record these observations. So when we think about how to map our position somewhere on the earth, remember we talked about latitude and longitude, right? So let's say we're living over here in Glendora, right? We'll have a specific latitude, which will tell us how far north we are. And we'll also have a specific longitude that tells us how far east or west we are. But there's a third piece of information that we also need to know, and that's elevation, right? Oops. How high are we relative to sea level? So today what you're going to be doing is figuring out how to interpret Google Maps using the topographic layer. So if you pop up your lab here, it says open Google Maps app on your phone or computer. So you can use either one, will work. Then it says click on the map type button. Looks like layered squares near the compass. Then click on terrain mode. You should now see the landscape as a topographic contour map of elevations. Okay, so let's go back and do that. All right, here's the 3 lines menu. And then I'm going to go down to terrain. Right, you can see the little mountain here. And you may notice there's other choices too. You can get the satellite data if you want. So satellite is taken from above. And you'll also be using this in the lab because I'm going to be asking you questions about which areas are heavily vegetated and which areas are desert. So you can see here it's very green out here in the national forest. I mean, that makes sense, right? But then we go out into the Mojave in the desert and you can see it's very brown, right? There's not much green, no vegetation. So that's how you check for that question. And the map is, this is the conventional map we use for driving. But right now we're going to go to terrain. So have that load up. So now what we can see is the elevation, right? So we're getting a better feel of how the landscape varies with height as we move from east to west or north to south. So let's go back up here to Los Angeles. Oh, look, you guys, there's a town called Corona. I wonder if anyone's living there right now. Okay, so if we zoom in here and just double click, or also in the bottom, there's this little plus sign. It says zoom. And you might see, you can start seeing already these lines here. These little squiggly lines. This one here you can read says 5,200. This little line says 4,800. Let's zoom in a little bit. So each of these lines, right? Each of these lines represents one elevation. So if I'm at the 4,400 here, anywhere I go, if I stay on this line, this 4,400 line, I will always be at 4,400 feet of elevation. If I go down in elevation, say, and I go over to this line, 3,600, if I stay on this line, I will never climb in elevation. I will never lower in elevation. I will stay at 3,600. So these lines are called topographic lines. And we're going to talk more about them in next week's lab, where you'll have exercises and you'll get to draw some topographic lines and do some really simple math with calculating elevation. But today is more of a introduction really to how we use topographic maps. Because a lot of times I get students who will say, oh, topographic maps, that's so dumb, right? Who uses this? We just use Google Maps. And that's true, we do use Google Maps, but we also use topographic maps with that. So it's important to see. I like to show you what you can do with things before you really learn the basics here. So topography, right? Topography, that is a function of the elevation of the landscape, and not just the elevation, but the shape, right? Is the shape more angular or rounded? And what does that mean about a landscape? So for example, if we look back at your lab here, okay, it's gonna ask you to go to places in the US and describe the landscape, right? So I won't give you all the answers for this, but let's do an example of what one of the things I'll ask. I'm lost. Okay. All right, so let's actually go to Oregon. All right, here is beautiful Oregon. And hey, look, the first picture that comes up is Crater Lake. That is the caldera I told you guys about that blew its top and formed this beautiful lake. So let's zoom in here and see what kind of features that we can detect from the topographic map. Let's zoom in. All right, so now I'm zoomed in over here, and we've got this thing called South Sister. Interesting. Very pointy in shape. Broken top. Another mountain, very pointy in shape. Let's continue north. So and notice that these pointy mountains, right, the base is circular. You see how these topographic lines, if I zoom in, they encircle that cone. So some of you may know that this is a volcano, right? And here's some little baby volcanoes over here too. Look at that little baby scoria cone right there. Another baby volcano here. And how I know that these are volcanoes is because they don't form a continuous mountain range, right? They're sort of like these little dots, these pimples on the landscape, right? Whereas if we go over to, let's say, well, we'll go back down to Los Angeles. We don't have any volcanoes, right? But we got enough shit going on here. All right, so if we go down to LA, we can see we got tons of these pointy landscape features, but they're not volcanoes. You can see it's this big continuous chain of rocks. It's not a little isolated, pimple or dot on the landscape, not, spherical or conical in shape. So that's how you, oh my God. So that's how you use topographic maps to determine your surroundings and to figure out, okay, well, how far do we have to drive before we're out of this mountain range? Or maybe you're looking to go find a new volcano. Think back to that video we watched, Killer Volcanoes, and the scientists had to search, right? Where is the volcano that destroyed everyone? They used programs like this to look, right? To look for unidentified volcanoes. So you're going to be using Google Maps today. And we'll just visit your lab back here. Make sure you have everything you need. Okay, so you'll look for Humphreys Peak. You're going to answer these questions. And then you're going to also, don't forget to load your vegetation using the satellite layer. I discussed that at the beginning of the video. Okay, your final question, or one of your final questions. For number 8, you will have to research this online. But for this one, I can sort of get you started. You decide to take a road trip from LA to the east coast of North America, which, of course, don't do that right now, but, maybe in a month or two. And you love geology, obviously, so you keep a diary of what you observe along the way. Using Google Maps, plot the route you would take. You can choose any city on the east coast as your destination. And you're going to describe the change in elevation and vegetation along your route. Okay, so I want you to be as detailed as possible. Okay, I don't want just 3 stops. Oh, look, I made it. I'm in New York. No one's here. So let's zoom out here. You're going to pick a route from LA to any one of these cities. So let's see. I'll do an example. Where do I want to go, you guys? Maybe let's go to Philadelphia. I don't think I've ever really been. All right, directions. Choose a starting point. I'll say Citrus College. Citrus College. Okay. So, let's see. Oh, 40 hours, not bad, you guys. All right, so now as I'm going along this route, I want to describe my changes, right, in elevation and vegetation. So we can see we have a really green region where we start out, actually, in the Los Angeles National Forest. Then we hit the desert, right, pretty low in elevation. Then we drive through the Mojave Preserve, so we get a little bit more green there. And continue onward, and we can see we start to increase back in elevation. Oh, look, there's Humphreys Peak. You guys are going to explore that area in the lab. So you can see as I drive through how the landscape is not constant, right? It varies, and you're going to describe what you see along the way. Right, where were the flattest points? Where were the highest points? Where were the greenest points? And now we're in this really boring stretch. Oh, this is Oklahoma. Yeah, not much to see here. Okay, wow. Now we're in this really green region, the Ozark National Forest. So maybe we want to talk about that. So let me zoom out. Let me see where we're getting closer to. So we're out here in Missouri. Very green farmland, right? And look, what's going on down here? You see these big scars? Big scars in the topography, right? So these are these ancient fractures that we can see here. And then if we keep going west, look at this amazing feature. You can see this alignment from Pennsylvania through Virginia, North Carolina, Tennessee. These are the Appalachian Mountains. And they formed around 300 million years ago when this piece of North America collided with the rest of North America. And at the time, they were taller than Everest, right? They were gigantic. But since that was so long ago, they've eroded down into kind of these smaller foothills, you know. People on the West Coast like us, we don't really call them mountains. They're like hills, right? But you can see that reflected in the topography, in the topographic layer. If I went over here, I took this off and I went to, let's look at another layer, satellite, right? We can see all of the rich greenery that is bordered by these individual basins of less green, less heavily covered vegetation because of the lower lying area. And we can also go back to our map too, right? And you can really see how little is shown by the map layer. You wouldn't really be able to tell these were mountains. You'd have to use your terrain, your topographic mode to really get a sense of that, you know, that elevation change. Okay, so let's see. Have I made it to almost to Philadelphia? Okay, I'm there now. Whew. So that took me a while. It took me about 40 hours. Okay, so that's the lab. I hope that this helps. This is my first time doing an online lecture. So if you have any questions, you can ask me during the office hours. Okay, great. Thank you guys. Good luck.